Here's a step-by-step DSA, Data Structures and Algorithms Syllabus for beginners. Chat Step 1, Introduction to DSA. What is data structure? What is an algorithm? Importance of DSA in coding and interviews. Complexity analysis, time and space complexity. Big O notation, omega, and theta. Step 2, Basic data structures. 1. Arrays. Introduction and memory representation, operations, insertion, deletion, traversal, searching, two-pointer technique, sorting basics, bubble sort, selection sort, insertion sort, searching algorithms, linear search, binary search. HAR2, strings, string manipulation and common functions, pattern matching algorithms, naive, KMP, Rabin-Karp, anagram problems, palindrome checking. 3. Linked list, types singly, doubly, circular, operations, insertion, deletion, reversal searching, detecting loops, Floyd cycle detection algorithm, merge two sorted linked lists. 4. Stack and queue, stack, LIFO principle, applications, undo, recursion, queue, FIFO principle, applications, scheduling, implementation using arrays and linked list, special queues, DEC priority queue. Depth 3. Recursion and backtracking, basics of recursion, base case, recursive case, factorial, Fibonacci, Tower of Hanoi, backtracking, N-Queen, Sudoku solver, rat in a maze. Step 4, advanced data structures. 1. Trees, binary tree basics, tree traversal, in-order, pre-order, post-order, binary search tree, BST, and operations, lowest common ancestor, LCA problem, AVL trees, B-trees introduction. Heaps, min heap and max heap, heapify and heap sort, priority queue using heap. 3. Graphs, graph representation, adjacency matrix and list, BFS, breadth first search, DFS, depth first search, shortest path algorithms, Dijkstra's, Bellman-Ford, minimum spanning tree, Kruskal's, Prims, topological sorting. Step 5, greedy and divide and conquer algorithms. Greedy algorithms, activity selection, Huffman coding, divide and conquer, merge sort, quick sort, binary search variations. Step 6, dynamic programming, DP. Introduction to DP, top-down and bottom-up approach. Fibonacci using DP, knapsack problem, 0-1 knapsack, longest common subsequence, LCS. Matrix chain multiplication, DP on trees and graphs. Step 7, advanced topics, bit manipulation, disjoint set union, DSU, try data structure, segment trees and Fenwick tree, string algorithms, Zed algorithm, Aho-Karasik, computational geometry, convex hull line intersection. SHA Step 8, practice in competitive programming. Solve problems on platforms like LeetCode, CodeChef, Codeforces, participate in contests, work on real-world applications of DSA, pathfinding, scheduling, AI-based search. Would you like a structured roadmap with problem recommendations at each step?